solution of equation of SHM. Solution of equation of SHM. Okay, let's see here. We already know the force equation better. Force acting on a particle is restoring force. F is equals to minus of your K into your X. K is known as force constant. F is nothing but your restoring force. If I write this force from Newton's law, F is equals to m into your A, I can be writing this acceleration as A is equals to your minus of your K by your m into your X. Can I write like this bit?
Yes, sir.
Isn't it? Now, can I write the acceleration in terms of velocity and position better? A is equals to V into dV by your
dt
dx.
dx.
Isn't it?
Okay.
Dx.
Yes, sir.
A is equals to dV by dt.
Yes, sir.
In place of your x, I can write A is equals to V into dV by your dx. That is equals
Okay,
to
sir.
minus of your K by your m into your x. Okay. So dx you take on this one. So this will be equal to your integrating on the given condition. Integrating on both sides. Integrating on your both sides. I can write this one as integral of your v into your dv is equals to, this will be equal to your minus of your k by your m is a constant, because k is a constant, m of the mass of the particle is also constant. This dx will go here. This is your integral of your x into your dx. Can I write like that? So
Yes,
integral
sir.
of your v into dv is equals to minus of k by m into integral of your x into dx. Integral of v into dv is how much better? Integral of your v into dv is how much? This formula we already know. Integral of your x to the power of your n into your dx is equals to your x to the power of n plus 1 divided by your n plus 1.
Divided by n plus
So it
1.
is
Yes,
integral
sir.
of v to the power of 1 into your dv. So that is equals to v. So I can write this one as v 1 plus 1 divided by 1 plus 1. So this will become for me how much? V square divided by 2. So integral of v into dv is how much beta? It is your v square divided by your 2 is equals to your minus of your k by your m into integral of x into dx is how much for me beta? X
X square
square
by
by 2. Plus along with that one we'll be getting some constant beta, that is equals to your c. Okay,
yes,
every
sir.
time with the difference in this integration we'll be getting some constant. That constant I'm taking it as of c. So this is the solution of this equation right now what I have written here. So v square by your 2 is equals to minus of k by m into x square by 2 plus of your constant c. At extreme position, at extreme position, at extreme position, x will be equal to your a. A is nothing but what beta? Amplitude. And velocity will become 0 because the particle go to the maximum position, stop there for a small interval of a time, again come back to the original position. Kada. If you throw anything into the upward direction, what happen? It will go to the maximum height, it will stop for a fraction of a second, again it will come back.
Yes, sir.
Ana kada. So when it is stopping means what is the final velocity at extreme position? It will
0,
be
sir.
equal to 0, and maximum displacement is equals to known as of your amplitude. So x will be equal to your a. So in this one, if I'm taking the v is equal to 0 at extreme position, so what I'll be getting right now, see here right now. So this will become for me 0, that is equals to minus of your k into, in the place of your x, this will be equal to how much for me? A. So this will become for me a square divided by your 2 into your m plus some constant of your c. So this constant value I'm getting how much for me? C is equals to k into your a square divided by 2 into your m. So this is the value of your constant what we got. K is a constant, maximum amplitude is a constant, 2 is a constant, and mass is also constant. This is a minus kabati. If it is goes this side, it will become for me plus. So that constant value, how much I got beta? C is equals to K into A square divided by 2M. See, this is a basic equation, na beta. Now, in order to get this constant part, what I am doing is at extreme position, I am taking the x value is equals to A and velocity will be equal to 0, because in
0.
a simple pendulum, if I am taking this one as of your simple pendulum right now, this is your mean position. So when you give a small jerk, it will go to the highest position somewhere here right now. And here for a fraction of a second, it will try to stop. Again, it will come back to the original position. Ante kada? So it will be
Yes,
making
sir.
to and fro about this mean position like this. So it is making the to and fro motion like this. So this is known as of your extreme position. At this extreme position right now, x will be equal to a and velocity will become how much for me? 0. So if I'm taking that value here, v is 0 in the place of x a, I'm getting the value of a constant is equal to how much beta? K into a square divided by your 2m. So now I can write therefore v square divided by your 2 is equals to k by your 2m part of relation. This is nothing but of your k by your 2m into your x square value will be equal to your how much for me? X value will be equal to your how much? Can you tell me right now? I already got the value of your constant. So what is the value of your constant right now here? K into your a square plus constant value is equal to how much for me? K into your a square. This is your x square. Kada, sorry. This one is your x square. Antena? This one. Minus of k by m into your x square divided by 2 plus constant. Plus constant value is equal to how much beta? K into your a. Here it is minus sign. Na?
Yes, sir.
So here it is minus sign. K into a square divided by 2 into your a. So I can write this one as v square divided by 2 is equals to. If I remove this minus sign and k by 2m as a constant, so it is k by your 2m into. If I remove this minus sign, I can write this one as of your a square minus of your x square. Can I write like that?
Yes, sir.
So velocity of this one will become for me how much beta? V is equals to your under root of your V will be equal to this 2 and this 2 here will get cancelled. So this will be equal to your k by your m into your a square minus of your x square. Okay. Now putting here right now the
Yes,
value of this will be a constant, that is putting under root of your k by your m is equals to your omega. So this equation will become for me how much? V is equals to your omega under root of your a square minus of your x square. So this is the velocity of the particle of your SHM. So V is equals to your omega under root of your a square minus of your x square, where omega value is how much beta? Omega value is under root of your k by your m part of relation. Is it clear? Okay. Now
yes, sir.
see. So can I write now this velocity in terms of position beta? V is equals to, this can be written as of your dx by your dt is equals to, this is some constant that is omega under root of your a square minus of your x square. So this dt I'm taking on this side right now. So this will become for me dx divided by, this is under root of your a square minus of your x square is equals to omega into integral of your dt. Now dx by under root of a square minus x square is how much beta? See this integration. Under root of 1 by x square, 1 minus x square into dx is how much for me? Sine inverse of x. In the place of your 1, I'm having a square. In the place of x, I'm having your x square. So this total value of integral is how much for me? Or sine inverse of your x. So that I can write here right now. This total value will become how much better right now for me? Sine inverse of your x by your a. X by your a is equals to your. This will become how much for me beta? Omega into your t. Omega into your t part of relation. Okay, na?
Yes, sir.
Plus some constant with it one, that is nothing but of your phase. So if I'm writing right now this one, sine inverse of x by a is equals to omega t plus of your phi. So from this one I can write x is equals to your
So, sir, phi
a,
is the constant, sir.
this, yeah, phi phase is a constant. I'll tell you that one again in detail. That is called as of your phase angle. Okay,
Okay.
that I'll tell you right now. Okay. So this x by a sine inverse, you take this one, this will become for me positive. A will also will go here right now. X is equals to your a into your sine of your, this will be your omega t plus of your phi. So this is your solution of your simple harmonic motion equation. So when a particle is being projected in your linear SHM, the position of that one can be calculated by the formula x is equals to your a into sine of your omega t plus of your phi. X is nothing but displacement from the mean position. Omega is your angular frequency and a is your amplitude beta. So what is your x beta? X is nothing but your displacement. X is your displacement from the mean position. Displacement from the mean position. Displacement from your mean position. And omega is what beta? Omega is your angular frequency. Omega is your angular frequency. And capital A is what beta? Amplitude. Amplitude. Amplitude is nothing but what? Maximum displacement. Okay. So this is the
Yes.
solution of SHM. X is equals to A into sine of your omega t plus of your phi part affiliation, where phi is known as of your phase angle, where phi is known as of what for me? Phase angle of the given particle part affiliation. Is it clear? Okay, so what is the solution of an
Yes,
equation
sir.
of beta? X is equals to a into sine omega t plus phi part. This derivation I have done it for your only understanding beta, but this derivation is of no use for you in the coming part of relation. But once you remember the basic relation and basic equations right now from that one, how do you got the velocity? In this one, this velocity formula is very, very important. That is V is equals to your omega under root of a square minus of your a square minus omega into under root of a square minus of your x square, and this equation x is equals to a into sine omega t plus of your phi part of relation. Is it clear?
Yes, sir.
Okay, so this is your expression. So any expression which satisfy the differential equation of your d square x by dt square plus omega square into your x equals 0 will represent your SHM, will represent your the SHM part of relation. Okay, so this is the way we can talk it about. Or else we can do this one also by this method beta, which we call it as of your in your NCRT. It is given as something like this. This is given as of your projection of your uniform circular motion. Projection of your uniform circular motion. Uniform circular motion. Projection of your uniform circular motion is your SHM. That means any particle which is moving in the circular path is also be said to be assumed to be making an SHM particulation. See how is that happening? I'll tell you a rough idea. So this one is your, let's say for example, of a circle. Okay, and this is your x-axis and this is your y-axis. Okay, now assume a particle somewhere here at t is equals to 0. Okay, beta, at t is equals to 0, the particle is somewhere at this position, and simultaneously assume its shadow is here right now. This is the shadow of this particle, or assume this has been connected like with a spring. Okay, if this move up, this also moves up. If this move down, this also moves down. Okay, na? So this is the original particle of mass m. The shadow of that particle is projected along the diameter of this circular path. So consider a body which has been revolving in the uniform circular motion beta with a constant angular velocity of your omega. So what we do is consider, okay, consider a body, revolving in uniform circular motion, revolving in the uniform circular motion with constant angular velocity, with constant angular velocity omega. అంతే కదా, this particle will be moving with your constant angular velocity of your omega, circular path కాబట్టి, isn't it? So then its projection will be moving along what beta? Then its projection, is along the diameter. Projection means what? Shadow.
Yes, sir.
దీని యొక్క shadow is been along the diameter of the particle part affiliation. Is it clear? Now say for example, this particle has been gone from this position to this position beta. Assume this particle has started right now here and it has reached to this position. At what time? At t is equals to, like say for example, t seconds. Okay, now what is happening? The distance from here to here, this will represents for me the radius, that is nothing but a full r, and it has been moved by an angle of your theta. This theta will be equal to your omega into your t part of relation. Now, where will be its shadow beta? Can you tell me? Its shadow is somewhere here right now. The shadow of this particle is somewhere here. So this has been moved by how much in the upward direction? Y. Okay, na?
Right.
Like assume something, they are both of them are connected by the spring. When they go up slowly, the spring is getting compressed. When it is been coming in
Yes,
the
sir.
downward direction, that will getting extended. So when here it is, then right now when this particle, the maximum distance between them was equal to the radius. అవునా కదా? From here to here, this will be
Yes, yes.
obviously will be the radius. This maximum radius is known as of your amplitude. అంతే కదా? Maximum distance between these two
Yes,
particles
sir.
is this only,
Maximum
na?
displacement.
So this
Yes, sir.
maximum distance is
Yes, sir.
nothing but of your amplitude of the particle, and this is your origin of the particle, that is nothing but of your O part of relation. So now let this y be the displacement of the projection after t seconds. So I can write here right now, let y be the projection, or y be the displacement, y be the displacement of a projection, displacement of your projection after t seconds, after your t seconds. Then then from figure, then from figure, what I can write beta? So I know this theta, so this one is also your y kada. If this is y, this is also y, isn't it? So I can write from this one, sine theta will be equal to y by your a. Can I write?
Yes.
See the diagram? This is your y, this side by this side, this is theta. Antena? So
Yes,
sine
sir.
theta is equal to how much for me? Y by a. What is a beta here? A is nothing but your radius of your circle. A is your radius of your circle. So from this one, I can write y is equals to what? A into your sine of your theta. Theta is how much for me? Omega into t. So y is equals to A into sine omega into t. So this is
Yes.
your displacement of the particle after t seconds. So you can say this one is what? Displacement. This is your displacement of your projection. Displacement of your projection after how much time beta? After t seconds. After t seconds. We are starting from where beta? From origin. We are starting from where beta? We are starting from your origin kabatti. There is no initial phase. There is no initial phase. That means initial phase is equal to how much for me? 0, because there is no angle. Initial angle enta when I'm starting at t is equal to 0, 0 kada, because I'm exactly along this diameter. When I
Yes.
started moving with certain velocity, then only I'm getting this angle. So that is the reason whenever I'm starting from an origin, so the displacement of the projection will be given by the formula y is equals to your a into your sine of your omega t. Once I know the displacement, can I calculate the velocity beta? So velocity will be equal to your how much? Velocity is nothing but what? V is equals to your dy by dt. Can I write velocity?
Yes, sir.
So now I know the value of y. So substitute that value of your y. So v is equals to your d into y value is a into sine
A
of
sine
your omega into
omega.
t divided by your dt. So in this one you take a out. This is your differentiation of your sine of your omega t divided by your dt. Differentiation of sine is nothing but how much? This is sine chain rule. Differentiation of sine omega t will be equal to your how much for me? Omega you bring out from this one. So whenever you are doing the differentiation, sine of your omega into t. So from this one, bring out your a into your omega out, and differentiation of the sine will be equal to your cos of your omega into t. So this will be the velocity. So velocity of the particle will be equal to this. I told you already in the differentiation beta. So V is equals to your A omega into your cos of your omega into T part of relation. Okay, na?
Yes, sir.
So this is a chain rule beta. You can just cross check with your chain rule formulas of a differentiation. There will get, you assume this totally as of X beta. Okay. So this one is your
Okay.
omega into T part of relation. So first differentiation sine of your X, then differentiate the value of your X also. So if I take this one as of your X na beta. So if I'm taking, I'm just roughly giving an answer. If I'm assuming X is omega into T is of your X. Differentiation of sin x is how much? Cos x. Substitute the value of your x back. Again differentiate this x. Dx by your dt. Omega will come out. So dt and dt will get cancelled. So I'll be getting the value of omega. Okay na?
Yes.
Okay. అర్థమైందా మళ్ళీ సార్ చెప్పిన దీని differentiation.
అర్థమైంది సార్.
Okay, chalo. So v is equals to a into omega into your sin cos of your omega t. Now can I write this one in terms of sin beta? V is equals to your a into omega. Cos omega t can be written as under root of sin square theta plus cos square theta is how much? 1 kada. Sin square theta plus
Yes,
cos
sir.
square theta. So cos
One.
theta will become how much
Yes.
for me? Cos theta will become for me 1 minus of your sin square theta. Can I write like this? Okay, so v is equals to your a into your omega under root of your, this is 1 minus sin theta value already we got. What is sin theta value? Y by your a. So this is nothing but of your y square divided by your a square. Okay, so if I take this a value also inside right now, so this will become for me how much? For me a square. So this will become for me how much? V is equals to this omega will be as it is right now here. This will be v is equals to your omega as it is. This a if I'm taking inside, it will become for me how much? A square. And here a square and a square will get cancelled right now for me, isn't it? So this will become for me how much? Under root of your, this will become for me under root of your a square minus of your y square. Vachinda?
Yes, sir.
Isn't it? So this is the velocity. In this way also we can derive it. Generally 99% the teachers will derive this one by the projection of this particle also. Even in NCERT, this is the method which has been given to calculate the velocity of the particle and also the what you call that one displacement of the projection of the particle. So this is the displacement of the projection of the particle. Y is equals to a into sin omega t if I'm starting from omega, or else v is equals to your omega into under root of a square minus of y square as of your velocity of your particle part. Is it clear?
Yes, sir.
Okay. Now, once I know the velocity, can I get acceleration better? So, how do you
Yes,
get
sir.
acceleration? Can you tell me? So, how do you get an acceleration? Acceleration formula in terms of your time. Chappo. Acceleration formula in terms of time. What is an acceleration formula? A is equals to dv by dt. A
Yes.
is equals to dv by
DV.
over dt. Antena? Acceleration is
Yes,
equals to
sir.
A is equals to dv by dt. So this one is A, that is equals to your dv by your dt. So this is your d. In the place of v, what I can write, you see? In the place of v, this is a omega into your cos omega t. So this will be equal to your a omega into your cos of your omega t divided by your dt. So this is your A, that is your D. So what are constants in this one? First you tell me. A and omega are constants. So bring it out. So it is A into your omega. Then this is the differentiation of your cos of your omega into t divided by your dt. Again, this is a chain rule. You assume this omega t as of your x beta. Differentiation of cos x will be equal to how much? Sin x.
Fine.
So this will be equal to your A into your, then differentiation of your x value. X is equals to omega into t kada. దీన్ని డిఫరెన్షియేట్ చేయమల్ల dx by dt la omega will come out. So this will be dt by dt. T and t will get cancelled. That will be equal to omega. So 1 omega, if it is coming out, already it is omega. So omega into omega, this will become for me omega square.
Yes.
Differentiation of cos will become for me or sine of your x. X values again I'm keeping it back. That is your omega into t. Is that clear?
Yes, sir.
Okay, so this is your A is equals to your A is equals to your minus part relation. Differentiation of the cos is nothing but of your negative. This will be your minus part relation. So A is equals to your minus of your omega square into A into sin omega t. How do you write beta? Can you tell me? A into sin omega t. See, A into sin omega t is what? Y. A into sin omega t is
Yes,
what
sir.
for me? Y. So this will be equal to your y I can write. So acceleration is equals to your minus of your omega square into your y part of relation. Isn't it? So this is your acceleration, the one which we have got in the initial condition. A is equals to minus of your omega square into your y part. So I can say this one is acceleration is your function of your y. And where y value is how much beta? Y value is equals to your A into your sine of your omega into t part of relation. Isn't it? So if you
Yes,
simplify
sir.
this one, I can say that omega square is a constant. Gadana. So A is directly proportional to what? displacement, but in the opposite direction. So this is the condition of your SHM. Acceleration is always directed opposite to the displacement. This is your condition for your SHM. This is your condition for your SHM. Okay, na?
Yes.
So what is the condition for SHM beta? Acceleration should always be directed to the displacement in the opposite
Yes.
direction. Opposite
Yes.
direction. So if we take the bob in upward direction, acceleration of the body is in the upward direction. Displacement of the body is in the backward direction, isn't it? So
Yes.
from this equation, I can write here as A is equals to your as A is equals to your as A is equals to minus of omega square into y. You take minus on this side, this will become for me A plus omega square into y is equals to 0. This acceleration can I write in terms of displacement beta? A is equals to d square y by over dt square plus of your omega square into y is equals to 0. So this is your differential equation of your SHM. This already I told you yesterday. This is
Yes, sir.
your differential form. This is your differential form of equation of SHM. Equation of your SHM. Clear? So any particle which is
Yes.
said to be obeying in SHM, it should obey this condition right now. So now, if I am saying right now, will you say that when a particle is moving in the circular path, is this the particle making an SHM or its projection is making an SHM? Now see, when the particle is here right now, when the particle is somewhere here right now, then the shadow is also on the same direction, but అవునా కదా? ఇది ఇంకా
Yes,
వెళ్ళిపోద్ది.
sir.
ఈ పాయింట్ ఇక్కడికి వచ్చిందనుకోండి, షాడో కూడా పైకి, both of them are meeting. So when the particle is going in this direction, in the first quadrant, the particle is in the upward direction. Now the particle has been coming right now. The particle is somewhere here అనుకుందాం. The particle is somewhere here. The particle is somewhere here. Again, the shadow of this one will be somewhere here, beta. Shadow of this one is somewhere here. The shadow of this one will be somewhere here. Again, that means the particle has been come back to the mean position. So from mean to it has gone to the extreme in the first quadrant. In the second quadrant, it is coming from your extreme to your mean. Okay. Again, the particle from the third coordinate when it is going in the downward direction. Again, this particle from the mean position will come back to the extreme position, and both the particles will meet here. Again, when the particle is been going in the fourth quadrant, the spring will get stretched. Again, this particle will be trying to move in the upward direction. So when the particle is moving in the circular path, it is not this particle, it is making a circular uniform SHM, but it is the projection which is making an SHM about the diameter. That thing you need to remember. Is this logic clear for
Yes,
us? When the particle is somewhere here, this particle is not making SHM beta. This particle is making a circular motion, whereas the particle which is along the diameter, it is making the to and fro motion. It is making for me to and fro motion part of relation. That is known as of your simple harmonic motion part of relation. So the projection of the particle along the circular path, it is not the particle which is making the circular path, but it is the projection along the diameter which is making the to and fro motion from mean to extreme, extreme to mean, mean to extreme, again extreme to your mean position. Is that clear?
yes, sir.
Isn't it? So now this is a basic condition. So when a particle is starting from origin, equation of an SHM is y is equals to a into sine omega t. Velocity in terms of cos will be equal to v is equals to a omega into cos omega t. Or in terms of amplitude and displacement, I can write v is equals to omega under root of your a square minus of your y square part deflation. And acceleration is how much for me? This is your acceleration formula beta. A is equals to your minus of your a into your omega square. In terms of your sine, if I'm writing, this is your maximum amplitude acceleration formula. A is equals to minus of omega square into sine omega t, or omega square you bring it out, so it is minus omega square. A into sine omega t is y, so A is equals to minus of your omega square into your y part deflation. So acceleration must be directly proportional to your amplitude, but in the displacement, in which direction beta? Opposite direction. This is the condition for your
Yes,
SHM. Okay na? See here.
yes, sir.
So this is a basic equation or basic condition for the differential form of your equation of your SHM part of relation. Is it clear?
Yes, sir.
Okay. So that is about your basic things. Now let us try to go for some terms used in the SHM beta. Terms used in SHM. terms used in your SHM. The first one is your amplitude. First one is your amplitude. First one is amplitude. What is an amplitude? I told you, beta. Can you define me what is an amplitude?
Sir, it's the maximum displacement.
Maximum distance. This is a mean position. This is the extreme position 1, and this is your extreme position 2. Okay, so the particle is going in this direction right now. The distance from here to here, I can call it as from here to here, whatever the displacement you are taking right now from here to here. Okay, this is your maximum amplitude. That is nothing but a area. So the maximum displacement of the particle from the mean position or from your equilibrium position. This M is also representing the mean position, E1 and E2 representing the extreme position. Then I'll be writing the equation right now for that one. X is equals to your A into your sine of your omega t. That means this X will be equal to how much better? Displacement of the particle will be equal to your plus or minus, because this amplitude can be a positive or in your negative part of relation. So this amplitude is nothing but of your X. So this X can be equal to plus or minus of your A part of relation. So I can say the definition, it is the maximum displacement. It is the maximum displacement of the particle from mean position, or mean position is also called as what, beta? Equilibrium position. Okay, na?
Yes.
Then what is the time period, beta? Time period formula. So what is the time period formula? Can you tell me? Next one is your time period.
Sir, it is the total time taken for a
For
particle to
one complete
complete an
oscillation.
oscillation.
Yeah. So one complete oscillation means what? Can you tell me? If the particle is moving right
Going
now like
from,
this, yeah, this is mean to extreme, extreme to mean, mean to extreme, again extreme to mean. Got it?
yes,
That means
one
from
second.
here to here, the time period will be T by 4. Again T by 4, T
Yes,
by
sir.
2. Again from here to here, T by 4. Again T by 4 to T by 4. So that will be T by 2. So
Yes,
total time period will be T by 2 plus T by 2. That will be equal to your capital T part F relation. Is that clear?
yes, yes,
Isn't it? That means one cycle is nothing but one cycle starting from the mean position of your EM to your E1, again from E1, then to E2, again back to your EM part deflation. That will be your that condition. That means if this is your mean position, this is your E1, and this one is your E2. This one is your E2. So the particle which is being taken right now, it starts from your mean position, goes to the extreme, come back to the mean, again goes to the extreme position, come back to the mean position. So this is your one time period. This is your one time period, or we can say this one is called as of your one cycle. This is called as of your one cycle particulation. So one cycle starting from extreme position E1 to your E2, again back to your E2 will also be the one cycle, isn't it? Like say if you say me, sir, I'll start from E1. So again E1 to your E2. So this one is E2. Kada. Okay. So I'll start from E2. E2 to your E1. Again E1 to back to your E2. This is also your one complete cycle. అంతే కదా నాన్న?
yes, sir.
E2 to your mean beta,
Yes, sir.
mean to your E1, E1 to your mean, again mean to your E2. That is one complete cycle. So
Yes, sir.
wherever it
That's
has been
also one
started, it
cycle.
has to come back to the same position. That is also called as of your one cycle. In one cycle, what is the
Yes.
displacement? Can you tell me? In
The
one
displacement is
cycle,
zero, sir,
very good. In one cycle, displacement is
because
zero. Yeah,
starting and ending points are same.
yeah. Starting and ending point are same. So displacement will be equal to. Then what will be the distance? Can you tell me?
Sir,
Here to here it is A.
we have to add. Yes, sir.
Yeah, we need to add A plus A plus A plus A.
Yes, sir.
So how
4.
much it is? 4A. Distance is that much,
Yes, sir.
isn't it? Now see from the equation of SHM, from the equation X is equals to A into sine of your omega t plus of your phi. Okay. T is your time period. T is your time period part of relation. So if I'm writing this equation right now, if capital T is the time period, if capital T is your time period, then X will be, or X will have same value at T and T plus of your capital T. Okay, so therefore I can write this is equals to X is equals to A into sine of your omega T plus phi, or else this one is your A into your sine omega into your, this one is nothing but T plus of your capital T, T or plus of your capital T plus of your phi, plus of your phi. Okay, that means I can write this one as of your A into your sine. If I multiply this one, this will become for me how much you see. So this is omega into T plus of your phi plus of your omega into capital T. Can I write like this?
Yes,
I'm
sir.
just multiplying this one, omega into T, omega into capital T plus of your phi. Okay, and now we know that, as we know that sine theta value can also be written as of your sine of your theta plus of your 2 pi. Ante kada?
Yes, sir.
Isn't it? So from this one, I can write here right now sine theta of your 2 pi part deflation. So what will be the given condition I can write here right now for this one? So X is equals to your sine of your omega t, omega into t plus of your phi. So this total sine t can be written as of your sine of your theta plus of your 2 pi part. That means omega t will be equal to how much beta for one complete oscillation right now. This sign and this sign will get cancelled right now for this one. So theta will be equal to how much for me? Omega into t. Antena?
Yes, sir. Yes, sir.
So I can write here right now omega into your capital T will be equal to 2 into 5. That means the time period will become for me 2 pi by your omega. So this is the time period. T is equals to your 2 pi by your omega part of the relation. Okay, so in terms of your constants, the time period of an SHM can be written by the formula T is equals to 2 pi by your omega. In terms of your T and in terms of your omega, the time period of oscillation is given by the formula T is equals to 2 pi by your omega part oscillation. So what is the time period beta? Time period is nothing but of your time taken to complete one cycle. After one cycle, particle will come back to the original position is known as of your time period. I can write the definition right now here. Time taken to complete one cycle, if it is stopping, it rejoin it better immediately. Okay, hello.
Okay, sir.